So our final part of our statistics study is going to be related to standard deviation. So far we've used range and interquartile ranges to describe the spread of data. Now the problem with using these is that they only consider 2 points to describe some type of spread. So for example, when we're considering range, we'd use the maximum value and we'd use the minimum value, and we could determine the spread of the data. Now that doesn't always give us a great understanding of what's happening in between those 2 points. So often a better way to describe the spread of data is using a standard deviation, because it uses all the data points to describe the spread. So there's 2 types of standard deviation we could be looking at. We could be looking at the population standard deviation, or the type of standard deviation which is more practical is using a sample standard deviation. So the problem with populations is that they're often large, so trying to gather information from every single individual is often impossible because there's so many people. So basically what we can do is we can take a random sample of a population, and we can use this random sample to represent the entire population. So just some notation. If we're talking about the sample mean, we use X bar. If we're talking about the population mean, we'll use mu. If we're talking about the sample standard deviation, which is going to be the main type of standard deviation that we're going to be using, you use an S. Or if we're talking about population standard deviation, you use a sigma. Now, if we have a quick look at how standard deviation is useful in describing data, if you have a look at this distribution here, you can see that basically the standard deviation just tells us how spread out the data is. So if we consider this distribution, in the middle we have our mean, represented by the mu. Now here we have mu plus 1 standard deviation, or sigma. So, and on the other side we have mu minus 1 standard deviation. Now we can see that 60% of data in a set of data will lie within 1 standard deviation either side of the mean. 95% of the data will lie within 2 standard deviations, and 99.7% of the data will lie between 3 standard deviations. So again, standard deviation is a very good way to describe the spread of data. So if we were to calculate the population standard deviation, we can use this formula here. So sigma is equal to the sum of, so this is saying the sum of. Now mu, remember, is mean, the mean value, and x is our value. So we're trying to see how far our value deviates away from the mean. So for example, here they've got a data set 2, 3, 5, 9, and 11. We can find the mean of that data set by adding each of the values and dividing them by how many values there are. And then if we wanted to go x minus the mu, we could, x minus the mean, would go to each of these data points and would see how far the mean deviates from them. And you can see that we can find the sum of the squared values of those. Now that might seem a little bit confusing, but we'll shortly do an example. And then I'll show you how to use your calculator to solve them, which is actually a lot quicker and easier, especially when we've got large data sets. So let's have a quick look at this example. A supermarket manager is interested in the number of items customers buy. She takes a random sample of 6 customers. So again, she's taken a sample of the total population. So we don't know how many total people have gone to the shop, but she's taken a sample of the number of products people buy. So if we want to find the mean, we should be comfortable in doing this. And again, our calculator can also help us out, but we could do this by hand. by adding each of these up and dividing them by the number of data points. So you can see we've got 1, 2, 3, 4, 5, 6. So our n is equal to 6, and we would do the addition of each of those values to, if we have a look here, so to find the mean, we have the addition of each of those values and we divide them by how many there are to determine the sample mean of 8. Now, part B. This is the new part, to find the sample standard deviation using this formula. So again, this looks slightly complicated, but it's not too bad if you just bear with the process. So we've determined that the sample mean is 8. So I'll just quickly open up my document camera. Okay, so x bar, our sample mean is 8. Now, we're trying to find this value. Now, we're going to use this table to help us. So x is talking about each one of these data points. So I'll start off by listing each of those values, and we'll do it in the same order that they've done it. So 7, 11, 8, 2, 15, and 5. Now, our second column. So you can see what we're trying to do is we're trying to sort out this bit in here, the sum of all of these data points minus their mean squared. So let's take this data point and subtract the mean away from it. So our mean was 8, so 7 minus 8 is going to be negative 1. Then 11 minus 8 is going to be 3. 8 minus 8 is 0. 2 minus 8 is negative 6. 15 minus 8 is 7. And 5 minus 8 is negative 3. So I've taken my mean away from each of those data points, and now I'm going to square each of these values. So negative 1 squared is equal to 1. 3 squared is equal to 9. 0 squared is equal to 0. Minus 6 squared is equal to 36. 7 squared is equal to 49. And minus 3 squared is equal to 9. So now you can see that I've found the square of each of those. So I've found these. Now what we have to do, this symbol here means the sum of. So it means that we have to add all of these up. So 1 plus 9 plus 36 plus 49 plus 9, etc. It comes out as 104. So the sum of all of those values was equal to 104. So now you can see if we want to substitute the value into our formula to find our standard deviation, S is equal to the square root. Now we've worked out what the sum of all those things is. It's 104 over n minus 1. Now n, how many data points did we have? 1, 2, 3, 4, 5, 6. Subtract 1. So we have over 5. So we have to take the square root of that value. And if you put it into your calculator, it should come out as 4.56. So we found the standard deviation. So if you were to consider this graph that we had before, now again this is talking about a population mean rather than talking about a sample mean, but the principle is still the same. Here we have, if this was our mean, all the sigma is represented by that standard deviation that we just found. So we would know that 68% of our data would lie within that range there, the mean plus our standard deviation and the mean minus our standard deviation. Now, that process can become quite time consuming if we had lots and lots of data points. I mean, I only had 6 data points and I had to go to a fair bit of effort to subtract the mean away from each one and then square each of those values and then add them up and then put them into this formula to find the standard deviation. So what we can do to make our lives easier is we can use our graphics calculator. So I have gone ahead and put each of my values in, 7, 11, 8, 2, 15, and 5. So if I go calculate and then one variable, we can see our mean, our sample mean, is equal to 8. Then if we move on down, our number of points is equal to 6. And our, oops, I think I've gone past it. Our standard deviation, here you go, is equal to 4.56. So that would tell us our sample standard deviation. Now on your calculator, it will look slightly different. You should have SX, whereas my calculator, which is the older version, has slightly different notation. Now, what we can use the standard deviation to tell us is basically how spread the data is. If our standard deviation number is small, that means that the data is quite close together and the values do not deviate much from the mean. If this value is larger, it means that our data is more spread, and it means that our data deviates more from the mean.